Hello friends, this video on ray optics part 46 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 45 before going ahead with part 46. Let us now talk about the next optical instrument, that is the microscope. So what is a microscope? You would have seen this, maybe you would have worked with microscope in your science labs. So it is an instrument that gives an enlarged image of a minute object. So that means you have a very small object and you get a very magnified image of that object. So the magnification plays a very important role in case of a microscope. So even inside the microscope there is nothing but a combination of lens. Some lens is only there inside the microscope which magnifies the image to that extent. So let us see. Now there are two types of microscopes. One is a simple microscope and the other one is a compound microscope. So now we will discuss the simple microscope, and then we will see that why was the simple microscope not enough, or why was there a need for another advanced microscope which was known as the compound microscope. So let us start with the simple microscope. Simple microscope is nothing but a convex lens. That's it. So if an object is placed very near to a convex lens, the image which is formed is a very enlarged as well as erect image. So that is what is the purpose of a microscope, right? In microscope, we want to view an object, and generally we view it very closely. For example, you would have seen in the microscope in your lab that if you want to see some tiny object, you don't keep that object miles away and then try to view it with the microscope. So you keep that object closer to the microscope and then you view it. That means the distance of the object from the microscope is very near. So the object is very closer to the lens. And what we want a magnified as well as erect image. So for this convex lens is a suitable lens. I have already discussed about these kind of image formation. If this is my object, a ray parallel to the principal axis, after refraction passes through the focus, another ray passing through the optical center goes undeviated. So these two rays, if they go ahead, it looks like they are going away from each other. So if we join them backwards using these dotted lines, we see that they appear to meet at this point. So this gives rise to a magnified erect image. So this was the simple microscope. So that means simple microscope was nothing but a convex lens, a simple convex lens. You would have seen sometimes, if you have ever been to an astrologer, you would have seen that they have got a magnifying glass, right? They call it a magnifying glass. They'll keep that glass on your palm and then they'll see the lines of your palms. So that is nothing but a simple microscope. It is nothing but a simple convex lens which gives a magnified image of a closure object. Right? So now it was then observed that the magnification given by a convex lens alone is not enough. There are so many minute things which we want to observe. For example, there are minute organisms like bacteria or small atoms, and so many things, so many tiny objects are there which have now become visible because of high resolution microscopes. So they felt that the magnification provided by this simple microscope was not enough. So what they did, they tried to do something to increase the magnification. Now we will look at the magnifying power of a simple microscope. I mean, why did we, just now I told you, right, that simple microscope is nothing but a convex lens with the object placed very near to the lens. So why did we choose this arrangement? So let us look at the magnifying power of this simple microscope. We will see that how the magnifying power in this scenario is maximum and what is the limitation of simple microscope. Why the magnifying power cannot be increased to a very high value. So let us have a look at that. Let us consider two scenarios here. In the first scenario, what do we see? That the object is placed at the focus and the image is formed at infinity. So in this first scenario, image is at infinity and the object is situated at the focus. And in the second scenario, it is told that if an object is placed at a distance which is equal to the least distance of distinct vision. So this represents least distance of distinct vision. That is also known as near point. So if an object is placed at a distance d, in that case, the object is very clearly and distinctly visible to the eye. Now what happens in this case when the object is placed at the principal focus, the image is formed at infinity. In that case, the eye is the most relaxed position. The eye is not at all strained, right? Because in that case, the ciliary muscles are relaxed, so that the focal length is at its maximum value and the image is formed on the retina, right? In this case, when the object is at the least distant of distinct vision, even though the object is visible clearly, but the eye is little strained when compared to the first scenario. So now let us try to calculate the magnification in this case when the object is situated at focus and the image is formed at infinity. Now in this case, the angle which is subtended on the eye is theta I, right? So theta I, or let me call it as theta. So theta is the angle which is subtended on the eye. So from here we can say that since we are dealing with small angles, so instead of tan theta we can write it as theta, which is equal to, what is this theta in this? If you look at this triangle, you can say that theta is equal to h by f. And what will be this theta naught in this case? It will be nothing but h by d. Right? So now if I want to compare, if I want to calculate the magnification of a simple microscope, then let me consider the scenario of the simple microscope. In simple microscope, what do? We bring the object even more closer than the focal length. So right now the focus may be somewhere here. So the object is brought even closer than the principal focus. In that case, what happens? An image is formed quite nearer in such a way that the image is formed at a distance equal to capital D. That means this is the least distance of distinct vision. So this is my image and this is my object. So right now the image is at least distance of distinct vision, right? So in this case the eye is strained. The eye is definitely strained because I told you here also the eye is strained, but at least it can view the image clearly and properly. So now let us talk about magnification. Right? So when we consider these two, considering this scenario, what do we see here? In this case, we see that D is greater than F in this case. Now, if D is greater than F, this will imply that theta is if D is greater than F, this would imply that theta is greater than theta naught, right? So when I talk about magnification, right, because this scenario is nothing but a combination of these two scenarios, right? So we can say that, so when we are calculating the magnification is nothing but theta by theta naught. So this is h by f divided by h by d. So which comes out to be d by f. So the magnification is greater than 1 if d is greater than f. So this is what we achieve. That means we can increase the magnification to greater than 1. That means the image will be larger in size than the object if capital D, that is the least distance of distinct vision, is greater than the focal length. Right? So that means the focal length has to be smaller, as well as we have to make the arrangement in such a way that the image is formed at least distinct of distinct vision. So how is it possible that we can increase this magnifying power even more? So for that, what we do, we decrease the distance of the object. So the object is now placed even before the focal length. Let us suppose this was the focus. Now the object is placed even before the focal length. So in this case, what will happen? A virtual image will form at a near point. At this point, eye is trained, but the image is seen properly. So now in this case, let us try to apply the thin lens equation, that is 1 by v minus 1 by u is equal to 1 by f. Now in this case, what is v? Image is formed at a distance d, that is minus d. What is u? U is nothing but minus u. Let me say this u is u naught. So this will be u naught. Therefore, we can write minus 1 by d plus 1 by u naught is equal to 1 by f. Now, if I multiply d on both sides, we get minus 1 plus d by u naught is equal to d by f. Or we can say d by u naught is equal to 1 plus d by f. Right? So now let us try to calculate the magnification in case of this simple microscope. So what will be magnification? It will be nothing but theta divided by theta naught. So what is theta? Theta in this case. What is theta in this case? It is nothing but h divided by u naught, because u is the distance. So this would be theta naught. Right? This would be theta. And what is theta naught? Theta naught is nothing but the angle subtended by the image at this point, which is equal to h divided by capital D. So theta naught will remain the same, because theta naught talks about the scenario when some object lies at a distance capital D from the eye. So this theta naught will be h by d. So from this we get magnification is equal to d by u naught. And from this expression 1, we know that d by u naught is 1 plus d by f. So this expression defines the magnification of a simple microscope. So what can we predict from this equation? We can see that m can increase only up to a certain limit. Beyond that, the image becomes very defective, because if you look at it, it is 1 plus d by f. Now the difference, the factor d by f actually determines how large the magnification can be. And it is seen that the magnification can only go up to a certain limit, and after that, if the image comes out to be very large, in that case the image is very much defective, because here we have assumed that the image is at least distance of distinct vision. Now if we try to bring the object even more closer, maybe the image size will increase, but since if the image also starts coming closer, in that case the vision will get blurred. So thus it was found that the magnification factor became a limitation for simple microscope. It was seen that it can increase only up to a certain limit, beyond which the image turns defective. So there came into picture. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.